Hello and welcome to this video on hardware with me, Miles Brining. Okay, so let's have a look at what we're going to be looking through. So it's going to be split into three sections. So we've got hardware, environments, and then networks. Okay, just a quick, just something quick here before we get going. If you're ever unsure on anything regarding minimum hardware specs and what operating systems are supported, whatever version you're looking at running SolidWorks wise, I'd always recommend going to this web address here. Now if you do that, it will give you a table, quite a nice table of what the minimum hardware specs are and whether the operating system is supported, as you can see here in this part of the slide. So yeah, you get hardware requirements, release notes, graphics cards testing as well. And also antivirus testing. So these two here are particularly handy. Graphics cards is very noticeable if you use the wrong driver. So you can either use this web address or use the SolidWorks RX tool, which is located in the SolidWorks folder in Start menu. If you're using 2013 or below. Or if you're using 2014, it has its own folder in the Start menu tree. If you're still using 7 or Vista, for instance, and it's called SolidWorks Tools in that case. So you'll be looking for, or just in the search, just type SolidWorks RX. On there, there's a diagnostics page, and then it will display your current drive and whether it's the right one. So there's two different ways there for graphics card testing. Again, antivirus would always recommend that you use an antivirus which has been approved by SolidWorks. Alright, and they do have an extensive list of items that are or companies that are supported. Okay, so what affects performance? Alright, so it's split into two areas here. So we've got the application environment and then the application software. So environment is what hardware you're running, okay, so for what CPU you're running and things like that. You've got software, so things like Windows, so Windows 7 or Windows 8. Also with software you've got what else you're running in the background, okay, so you're using Office quite a bit or any other programs which involve, a power hungry, which could be taking it away from SolidWorks. You've also got frameworks, so .NET framework is something that SolidWorks relies on to run correctly, and if you have an older version installed or the wrong version, it can cause problems. Shell extensions, so these are things that run through other programs, okay, so Explorer, Windows Explorer for instance, and Internet Explorer can run shell extensions and they can slow your system down. So if they're loaded into RAM and they're running all the time as a process, they can drain resources from your system. So yeah, for instance, like add-ins in Internet Explorer would be a good one for that. And then antivirus. What antivirus are you using? Sometimes if you basically a good example is if you turn off scanning for all SolidWorks files, it can improve performance. Alright, in your antivirus, so it doesn't look at the standard file types for SolidWorks every time you load them, or it scans them. That can make a big difference as well. And then you've got the application software, so the core SolidWorks. So what service pack are you running? Are you on service pack 0 or are you on service pack 5 for instance, or somewhere in the middle? As I say, there's between, you've got 0 and then 1, 2, 3, 4 and 5, and they're released throughout the year. 0's obviously when it's first released, which is normally around October time, and 5 is then normally released the following October, so just before or around about the same time that they release the next version of SolidWorks. Also what add-ins you're running in SolidWorks. So for instance, if you have all the add-ins turned on in SolidWorks, there's a lot it has to run in the background while you're using SolidWorks, okay, so they're all loaded and that can drain resources as well. Okay, so we'll look at hardware in a bit more detail now. So it's split into four sections. So we've got CPU, which is in the middle here in this triangle, and obviously connected to the CPU are memory, storage and graphics. So the first one we'll have a look at is CPU. So we'll look at processors, speeds and cores, commercial versus professional, and then we'll have a look at the generations, okay, so things, the type of CPU models that they're bringing out at the moment. Okay, so 64-bit processor, you might be thinking, well, what's that? Well, a 64-bit processor is something that's been out for a number of years now, I'd say at least 6, okay. It's all to do with the way the architecture, so to speak, of how the computer's built. 64-bit has a number of advantages through speed and also through memory size. So the maximum space that 64-bit can have is 192 gigabytes. All right, so that's a large number. So in RAM, okay, we're talking about RAM here. That's a large addressing space. Also has a larger virtual addressing space. So that is what it can. You can virtualize memory. All right, so how much it can have, and also physical addressing space. So that's more to do with the 192 gigabytes. I'd always recommend, if you're using SolidWorks, that you run a 64-bit processor. What can happen is, if you were running a 32-bit, for instance, I've gone out and bought a brand new machine. It's got 32 gig of RAM in it, for instance. All right. If I'm running a 32-bit operating system, I can only use 3 gigabytes of RAM. Alright, so hardly any of it. All the rest is wasted. It just sits there doing nothing. So I'd always recommend that you use a 64-bit. I think from next year's version, so 2015, I don't think 32 supported anymore. So at that point you'd have to update anyway. Also has an extended register set in 64-bit, so the algorithmic and logical operations, memory to register and register to memory operations can now operate directly on 64-bit, and that's to do with the way SolidWorks works with it, okay, and other programs. It makes better use of, as I say, the algorithmic and logical operations within the register set. So in general, okay, 64-bit is much better than 32. Normally, if you're unsure whether you're running 32 or 64-bit, the easiest way to do it is to right-click on My Computer or the computer in Start menu, alright, and go Properties, and then it will tell you in there whether it's if it says 64-bit on that window when you load it, and it's obvious. If it doesn't say 64-bit and has nothing there, it's normally 32. The other way you can tell is if you go into the C drive. With 64-bit operating systems, there will be 2 program files. There will be one that's just called Program Files, which is a 64-bit section of program files, and then you get another one which is called x86. So the x86 is actually almost like a code name for 32-bit operating system. Okay. Now you may be wondering, well, Hamid, why is there 2? And it's because for backwards compatibility with 32-bit, you can run some 32-bit applications on a 64-bit operating system. All right, you can't run it the other way around. Okay, so you can't run 64-bit programs on a 32-bit Windows operating system. Okay, right. So moving on. So that's the processor out of the way. Let's have a look at speeds and cores. So what is speed? Okay, when we're measuring processors. So basically it takes information from various input devices and then executes an instruction that has been given. So this is how we're measuring speed, okay? And then the CPU executes a certain amount of instructions within a group called a cycle. Alright? So the speed of the CPU is measured on how many cycles it can perform in a given second. So one cycle, so one set of instructions, if it does 1 per second, that's 1 hertz. Okay. If it can do 1,000,000 cycles per second, it's 1 megahertz. Alright. So obviously 800 megahertz is 800 million cycles, and then 1 gigahertz is 1 billion cycles per second. Alright. Now, many years ago, obviously people used to measure it in megahertz. These days most people do it in gigahertz. Alright. you can quite easily pick up a 2.4 gigahertz these days for hardly any money at all. In the past it used to rapidly increase in speed from the first one of the first PCs in 96, 95 even, when Windows first came out. They're around 100 megahertz, and it rapidly increased over the next 5 to 10 years up to going into the gigahertz. These days though it's kind of plateaued in speeds, all right, a little bit, and we'll talk about that in a bit more depth in a minute. So yeah, cycle, just to go through this, is it will fetch an instruction from memory, all right, it'll decode the instruction, execute the instruction in the core, and then return it to memory for use. All right. So these days you can overclock computers very easily. It does very much matter on what motherboard you're using within your machine. If you do buy a machine, like from a manufacturer such as Dell or HP, this may not be such an easy thing to do. But if you do like building your own machines, you may be able to make use of overclocking quite easily. And most Intel chips, for instance, you can overclock by at least a gigahertz without too much trouble. All right, so you can get better value out of your CPU. It does shorten the life slightly, but to be fair, the time you'll want to upgrade, which may be 2 or 3 years down the line, it won't run out in that amount of time. It won't damage it. Okay, so you can quite easily overclock them and get away with it. All right. Normally this is achieved by increasing what's called a multiplier on the motherboard, and then that is linked to what's called a front side bus, all right, which is what the motherboard runs at. Okay, so how all the components talk to one another, what speed they talk to one another, times by multiplier, is then that works out your CPU speed. When you up the multiplier and then you put more, you make it run faster. To achieve it running faster, you have to also put more volts through it, and by adding more volts, it also means that it actually runs hotter. So most chips these days, you can get away with a certain amount before you have to replace the stock heatsink, which is on top of a CPU. If you really going for it, you can use water cooling these days, and you can produce some very good results. You can get well over 5 gigahertz these days using water cooling, and that's from something that's running like maybe a 3.2 gigahertz standard. It can reduce the stability of the machine, but these days this is negligible. As long as you keep the machine cool and you feed it enough volts, crashing is not that frequent, to be fair. Okay, so a standard CPU layout is like this. We have, depending on what core you've bought, you'll either have 1, 2 or 4 cores. It's very unlikely you'll ever have 3. Okay, so the benefit of having multiple cores is you can multitask. So you can have core 1, for instance, running a number of cycles, so that they can all run them concurrently, in different programs can run through different cores, and you don't get any slowdown. All right, so I could be using core 1 for SolidWorks, I could be using core 2 for something like Word, and then maybe core 3 and 4 for doing a render or something in PhotoView 360 or something like that. So it allows multitasking basically. As I say, if you're running like a Intel i7, they normally have 4 cores, all right. i5s and below normally have 2 or 1 cores. Okay. One more thing with this. Normally, there's something since the Halem range of CPUs, which came out in 2008 or 9, I think it was. There's a new function which is called Turbo Boost. All right, this is it's normally in the i7 range. Okay, and what this allows the CPU to do is turn off specific cores when they're not in use. So this can save power. But what it can also do is, if you have a linear process, like you're rebuilding the feature tree within SolidWorks, that's a very linear process. You can't run it through all 4 cores in one go. It has to rebuild the feature one after the other. It will notice this, and what it does is it almost throttles up one of the cores to, say my CPU is running at, I don't know, 2.4 gigahertz, okay? What it can do is turn the other 3 cores off that it's not using, and then throttle core 1 up to say it will throttle up to say something like 3.4 gigahertz. So it's overclocking it itself, and then because it's turned cores 2, 3 and 4 off, that offsets the power requirement that needs to be put into the board, and also the heat that is produced. So obviously if you turn 3 other cores off, you're only at standard using a quarter, it's producing a quarter of the heat. So it's a nice feature they've done. So back in the day, you either had to choose between maybe one CPU which was a very high speed that didn't have many cores, or you had to choose a core with a CPU with multiple cores for multitasking. Now you kind of get the benefits of both, all right, for the same, for a good value. Okay, so here's a good example here. The top left is a photo view 360 render with 8 cores playing in real time, and then there's a single core in the bottom right which is playing at 8 speed. So if I just let that play through, and then you'll see the advantages of using 8 cores over 1 core. Now you might be thinking, well, hang on a minute, we talked about earlier about having 4 cores. Why is it 8 here? So what tends to happen is, with Intel's newest range of chips, there's something that's called hyperthreading, and hyperthreading takes 1 core and virtually splits it into 2 basically. It does have its advantages, alright, so it means it can process more things in parallel through the core. So in this instance, you can see here that it's a lovely render of a set of pints, and it's going a lot quicker on the top left here. All right, and it should zoom through and finish in a sec. There you go. So it's all done. So in the bottom right one, still got ages left. So there's a lot of advantage of using 8 cores over 1 in this case, or even 4 cores over 1. All right. Okay, so yeah, causal speeds again. Parts assembly and designs are normally suited for single core use, which are going very quick, where simulation and rendering normally they benefit from multi-core setups. So by using this turbo boost, which dynamically adjusts the speed through the core, you can get the best of both worlds. These days, don't use the clock speeds to compare across CPU generations. So, for instance, an Ivy Bridge core, okay, at 3.2 gigahertz is a lot faster than a Halem core, 3.2 gigahertz. All right, and it's to do with the way the architecture is built within the CPU. Okay, so they're constantly refining it to make it better. So if you can, try and get the latest range of processors, not an older one, because you may find, even though the clock speeds are the same, the performance is a lot different. The newer ones will be much better. Okay, so we'll have a look at consumer versus professional now. So you might be thinking, well, hang on a minute, what does that mean? So consumer basically means an i7, i5. A standard processor which you would normally buy in a, Joe Bloggs. When Joe Bloggs goes into the shop and buys a machine, that's what you get. And then there's another type which is professional, which is, especially in the Intel range, is a Xeon. Okay. Some people will sometimes ask, what's the difference between the two? And in SolidWorks terms, there's not a lot of difference. Alright, Xeons are more expensive, they're more stable, they run with less heat, and they're used for prolonged use. So normally within servers, which are constantly being used. Alright, Xeon also provides ECC support, so that's error checking and correction. Alright, and that's the type of memory that when you run process it or cycles through a CPU and it returns it into RAM, the memory will check that that there's no errors in the RAM when it was rewritten into memory. Alright, so it has a checksum at the end of every process to make sure it's right. ECC memory is normally slightly slower because it does have to use these checksums every time to make sure the data integrity is 100%. Obviously it's more stable, it's more expensive than standard RAM. Xeons can also be paired, so what that means is you can have two CPUs plugged into one motherboard. Alright, so you have a motherboard with two CPU slots. That means in theory you can have, if you're using hyperthreading, so remember that means if you've got 4 cores you can have 8 virtual cores running on it. That means in theory you can have 16 cores can be achieved with the Xeons. Okay, so say they're normally used for servers when you have a lot of people polling a server at the same time for different processes. So generations, okay, so how you're saying the hertz is the same. Why is it better? And it's to do with the instruction sets, how they're written into the core, and how it processes the data really. They have larger caches on them, so caches is like a buffer. It's a very, very fast set of memory that kind of sits between RAM, system RAM, and the actual CPU itself. It actually sits on the CPU. It's called cache. There's different levels of caches, alright, on the CPU, and it's incredibly quick. So it'll take it from RAM, load it into the cache, and then the cache will then push it through the CPU. It'll go back in reverse order back to the CPU, back to RAM. Sorry. So also you've got things like better branch prediction, means less processes are wasted. So sometimes it will process something in response, and it's expecting something else to happen, and it doesn't, and therefore those cycles are wasted, or it's done something for nothing. So by improving the general architecture and instruction sets that go through a CPU, you can improve performance. So here's a performance versus popularity graph. So we've got an Intel Xeon up here, alright, and then we've got an i7 here. So more popular is this way, alright, and then faster is obviously up here. So you can see the performance difference between a Xeon and an i7. There's practically nothing in it. The only difference is these are more popular, and it's normally because they're cheaper. Okay, so just bear that in mind. There's no real difference with having a Xeon over an i7. Alright, next thing we'll have a look at is memory then. So we've got the importance and usage, types of matching, speed, the amount, and then error checking. Okay. Okay, so what is it used for? So RAM. So random access memory is something other than cache, which actually sits on the CPU, it's the fastest type of memory that actually exists on a motherboard. What tends to happen is when you load a program, it's loaded from the hard disk into RAM, and then from RAM it's then pushed into the CPU to perform an instruction and then returned to RAM. So it's important that the RAM that we add in is actually fast. If it's not, it will produce a bottleneck. There's two reasons for this normally. Either you don't have enough RAM, or it's too slow, alright, or it's faulty, in which case you get loads of errors and it can then destabilize your machine. So a very simple concept would be that I open a picture from my hard disk into RAM, I apply a filter to the picture, for instance. The CPU runs instructions against the data in RAM to apply the filter, and then RAM holds both versions in it for the undo feature, just in case I need it, and then the CPU's idle again until the next instruction set goes through. Okay, so different types of RAM. Basically there's three main, well at the moment we're using something called DDR3, so it's double data rate, and there was double data rate 2 and then double data rate 3, so third gen. These days most people aim for DDR3 1600. Normally you'd match it with the bus speed. So as I talked about front-side bus earlier, so the bus speed is what megahertz your motherboard runs at, so how everything communicates with one another. What speed is that? If the memory is matching that speed, it normally produces a performance boost. Alright, so it doesn't have to do anything in recalculating the speed of the memory into the motherboard otherwise. You can overclock memory, alright. Sometimes, well, you can get memory that goes almost double that speed, so just be aware, you can do it. Matching is important, but these days it's not so important as it was maybe 5 years ago. So you can overclock it and get some good results out of it, as long as the motherboard, it's a good motherboard, which is good at overclocking. Normally you don't have to worry about any of this. If you're buying like a Dell or an HP or any other manufactured machine off the shelf, they'll do this for you. But if you're building it yourself, it's important that you get the right hardware, the right memory. It's compatible with your motherboard, and it runs at the right speed. So it's a nice pyramid here of, this is basically speed. You've got storage at the bottom, so like a hard disk or a solid state drive. You've then got RAM, and then you've got cache. So you've got level 1 and level 2. So the cache actually sits on the CPU. RAM obviously sits on your motherboard, in a slot, and then your hard drives obviously plug in via a. Normally these days it's by a SATA connection, so an SATA connection. Alright, okay. In the old days it used to be an IDE connection. So speed. So when you're looking at RAM, two things here really. When it comes to, when it says something like DDR3 and then a number after it, that number, so 1600 for instance, which is in this table, is to do with the data transfer speed. So when I say speed, I mean what megahertz it's running at. Okay. Normally the higher the megahertz, the higher the peak transfer rate. So DDR3 1600 is rated to about 12,600 megabytes per second, which is pretty, is a lot. The other thing is latency. So latency, rather than the transfer speed, is how quickly the RAM accesses data within it and then sends that data somewhere, for instance. So if I tell the RAM I'm looking for a specific set of data, the time it takes for the RAM to go and find it and then bring it to me is these numbers here. So you get basically a set of 4 numbers. What you're looking for is the lowest set of numbers. Alright, so 4448 for instance would be the lowest in here. I'd say most memory these days is is anywhere between 77721 and 99924. Okay, but you can get other ones. Obviously the lower the number, the more expensive it is. The amount, how much should I be using? So I'd always recommend a minimum of about 8 gig. Again, DDR3 1600. You can actually measure how much RAM you're using in Windows. If you have a look, if you go to Task Manager, so there's a number of different ways you can do this. If you hold down Control Alt and Delete and then go to Task Manager, on there you can get a very nice you get the processes screen, so you can, on that you can actually have a look at memory and see how much it's using. Normally you have a current limit and then a peak, and then obviously a limit would be how much RAM you've got in total. So if your current usage is getting very close to the maximum or total amount of memory that you've got, you know you're getting into trouble. what it does if it runs out of RAM, it starts throwing it onto the hard disk, and the hard disk is a lot slower than your RAM. So at that point, you're almost crippling your system because it's having to, store data where it shouldn't be. So on a source that's much slower. So yeah, if you can, try and always have the minimum amount. You can measure it during the day when you've got a large assembly open, for instance, and see what happens. And the last one is error checking and correction. So this is types of memory. Most people don't use EEC, so it's called non-EEC, funny enough. I say it's cheaper and faster normally. EEC is normally used for servers where it's it's mission critical that all the data must be 100%, so there's no errors going through it at all. You can only use it normally with Xeons, okay, or AMD's equivalent. All right. It's not something that you can run with a normal processor. Okay, so next thing we'll have a look at is storage. So we'll have a look at conventional disks versus solid state drives. So that's what SSD stands for. We'll have a look at speeds, RAID, any dangers that you can come across using the different types of drives, and then performance and adaptation graph for the different types. So the difference between the two are, so a standard hard drive has mechanical moving parts, they're cheap, and they have large capacities normally. These days at the moment you can go up to about 4 terabytes, which is pretty big. Solid state drives is pure memory, so it's flash memory, so no moving parts. It's very fast, so access to files is almost instantaneous. There's no seek time for the hard drive to go and find the data on the disk. They're more expensive than standard hard drives. Okay, so yeah, as I said, the read access time is very good. The write access time used to be slower than standard hard drives, but these days, with I think we're on about generation 3 or 4 at least now of solid state drives, the write speed has gone up quite a bit. So they used to be the only downside. The read speeds and data transfers for solid state against conventional hard drives is massively better. Okay, it's a huge amount. What we'd normally say is you'd use a solid state disk for your operating system. So you'd have things like SolidWorks, Windows, any other programs that you'd normally use, and then obviously any of your SolidWorks files on that SSD. And then anything else that's non-critical, like Word documents or videos or anything else really that it's not important about how quick it opens, we'd put on a standard hard drive. So normally SSDs will open SolidWorks and Windows about twice as quick as a standard hard disk. Alright, and it's to do with the time it takes for it to go and find the data and load it in. Let's say the read speeds are immense compared to standard hard drives. So here's a little comparison between the two. So power wise, solid state drives use slightly less, I say no moving parts. Cost wise, it's coming down these days. SSDs used to be massively expensive, but now they're getting cheaper every day. Standard hard disks are very cheap these days, and so you can get 4 terabytes for a pittance basically. Operating system, so averaging around 22 seconds boot up on an SSD, around about 40 seconds on a standard hard disk. There's no noise from an SSD compared to a hard disk. No vibration either on an SSD. Very little heat compared to a hard drive. Failure, in theory, solid state disks should last or outlive a standard hard disk. All right. File and write speed. So generally, from a disk, so you're reading from an SSD and copying it somewhere else, can be anywhere from 200 megasecond to 500 megs per second. All right. Whereas if you're copying it from a normal hard disk, it's anywhere between 50 and 120 meg. So massive difference there. Alright, and that obviously does make a big difference when you're opening files. Okay, so yeah, we've kind of been through this already. So generally above, SSDs are generally above 250 megabits per second when you're opening files, and then hard disks are normally anywhere between 50 and 120, and that's normally to do with the RPM of the drive. Higher the RPM, better the drive, quicker the seek time, faster the read rates. Normal drives normally run at 5,400 RPM. They go all the way from there up to 10,000, and then I've seen some that go even higher, up to like 12 or 13,000. Okay. Right, okay, RAID now. So for those of you who don't know what RAID is, it's a system that allows you to take more than one hard disk, so it's two for it, say two, and then combine them to act as one disk. Alright, that's one type of RAID. It's called striping. Alright, what this does is improve performance, because what it will do is it will take a file and it will split it into chunks. It's normally about 128k chunks, and it will put, so it split my file into these small chunks, and it'll put half on one hard disk and the other half on the other. And then when I query the file and I want to read it, it reads half from one and half from the other, and because of that, it means I get double data rate. You know, the data loads twice as quick into RAM. Well, it's not quite twice as quick, but it's definitely quicker than just having one hard drive on its own. Even with SSDs, it's pretty rapid if you have a set of SSD drives in RAID 0, so in striped mode. It does mean there's double the chance of failure though. So if you're in a striped mode like this and one drive dies, alright, so put a hammer through one of them, the other disk is worthless. Alright, they work as a pair, so it's double the risk almost. Okay, and then the second type is RAID 1. You normally get slower performance using this way, but increased safety. And what that does is, rather than two drives acting as one, is two drives where they mirror each other. So you'd have like a primary disk which you'd work from, and then any changes made to that disk would be mirrored onto the second disk. So if I put a hammer through one of them, the second disk is a complete mirror of the first, and then I can just boot off the first one, or the second disk, alright, the one I haven't hammered to death. And I've got a backup of the files. So they're normally used in servers, but so you can use it in a normal PC as well. Hard drives, okay, normally have an opportunity to warn you if they're about to die or let go. They normally make funny noises or don't spool up when you first start your machine. At that point you're like, okay, it's making a bit of a funny noise, I better get a new hard disk. SSD failures, on the other hand, you have no warning. You'll turn them on one day and they just won't work. So let's say normally they're rated for 2 million hours, so it's a long period of time. Normally it's getting better. I've had one fail on me before, but as I say, it was a first gen drive, so these days they're pretty damn reliable. If for any instance you're nervous about that with your files, there's a number of different things you can do. I would say work with them on the solid state drive, have a script to back them up onto a standard hard disk at the end of every day, and then you've only lost one day of work or half a day of work. Alright, or use PDM. So if you've got a workgroup vault, check it into that, or if you've got an enterprise vault, check it into that, and then you've got a backup which is on the server, which would be backed up nightly anyway. Okay, so I have a look at the pickup rate of SSDs now. So this is basically the Windows Performance Index. alright, which is being collated over 3 different years. Alright, so just imagine this here is the year we're in at the moment, this is last year, and this is the year before. Overall, the graph hasn't changed too much in performance. Alright, graphics wise, things are moving a little bit to the right, but where there's big changes in hard disks. So in this one, you can see hardly anyone was using solid states, just a small amount. So the performance index, if you're unsure of it, it runs from 0 to 9. Okay, 9's good, 1's appalling. Alright, so 6, you can see this huge peak. So this was what was holding people back on storage. Okay, whereas down here you can see as the pickup of SSD improves, more people are moving from this pinnacle here, okay, this high point, down to here. So you can see they've moved from 6 to 8. So that means that their performance overall, their score is better. Alright. So here's a little overview on opening times of assemblies in regard to solid state disks, a standard hard disk, and then over the network. Solid state, the first one is the quickest, is solid state in RAID, so that's striped. Alright, so that's 2 drives acting as one. Next one is just an SSD on its own. Then we have a hard disk and then network. So you can see, for instance, like a hard disk compared to network, it's almost double. Okay. Opening over a network does have its problems. Not only speed, but faulty hardware. If you've ever tried to save something over a network and it won't let you save over something or hit the save button, it's normally because the switch or the network card between you and the server or something on the server has failed. Alright, so a number of packets have become lost going through the network, and then the server's gone, oh right, there's nothing looking at this file anymore. I'll turn it back to read-only mode. Alright, and then when you hit save, it won't do it. So that's why things like Workgroup and Enterprise, you check the files out locally, so copy them from the server, work on them locally, which is a lot faster, as you can see from this graph, and then when you're done, you check them back into the vault. Alright, and then it copies it back over the network. So there's two here, there's 2 sets, so you've got a large assembly and then a normal sized assembly. So normal sized assembly, you can say, is a little bit quicker. When I say a large assembly, I've got an assembly with a large number of components which are unique. Yeah, so I haven't got a bracket that's been added in 5,000 times. I've got 5,000 separate brackets. Alright, I don't think this assembly actually had 5,000 brackets, so don't take me literally, but that's what I mean. So yeah, there's a you can see the performance change between those. So it's just an overview really. If you can, try not to use map drives. I know in some offices you all share the same data location. It is convenient, but as I say, it's slow. It is liable for file corruption over the network. If that's you think, well, how are we going to do it? Use a vault. If you've got professional, SolidWorks Professional, you're entitled to a vault for free. Okay, for Workgroup, use that. If not, you can always use Enterprise as well. SSDs are considerably faster than hard disks. Alright, they're normally about 5 to 10 times in price, but about 4 times as fast. Okay, so normally you'd boot with an SSD and have SolidWorks on it, and then all your files, and then you'd have an archive drive, which would be a hard disk, which you'd back up on, or back up onto the server, one or the other. Right, so the last one here is graphics. So what's the role of a graphics card? Drivers, professional versus gaming, and also some frames per second chart. So I don't really need to go in this much detail. I'm sure you can understand what a graphics card does, but it obviously allows you to view the models correctly. It takes into account things like colours and material properties, the actual geometry itself, lightings and shadows, smooth surfaces, removes jagged edges. Alright, that's called anti-aliasing. Okay, let's just move on. So drivers, again, if you're unsure about your driver, either use SolidWorks RX or go to this link and basically fill out the form, which you can see on the bottom right of the screen, and then it'll tell you what drive you need, and you can just download it directly from the SolidWorks website and then install it from there. You know you'll be running the right driver. People forget that service packs are linked to drivers, not releases. So if you're on 2014 service pack 0 and you install the right driver for service pack 0, when you upgrade to service pack 1, you may find that the driver that's been aligned with it is not the one you're currently on. So my recommendation is to at least every couple of months just check using either this screen or the RX tool whether your driver is in date. Right, the difference between professional and gaming. So professional, what I mean by that is an NVIDIA Quattro card or ATI Fire Pro. And gaming, for instance, like an NVIDIA GeForce card. Now GeForce cards do work, alright, but there is some limitations to them. First off, you can't have real view graphics. They are more buggy, okay. They're more liable to crash SolidWorks. They're not tested by SolidWorks, okay. Only NVIDIA Quattros are, so a professional graphics card. They're slightly slower, okay. They're not really designed for SolidWorks. I do know some people that do use them, and that's fine. The only problem is if you do experience an ongoing problem that crashes SolidWorks, and you phone, like for instance us up or whoever looks after you reseller wise, we can't do anything about it. Alright, SolidWorks or the graphics card are not interested in fixing bugs from GeForce cards. Okay, obviously if it's an NVIDIA Quattro card, they have a dedicated team that fix bugs against graphical issues against that service pack or against whatever SolidWorks version you're in. Whereas it's a GeForce card, there's no one. GeForce cards, the people that work for GeForce are only interested in making sure the game, they're interested in a number of things. One, what frames per second I can get out of games, alright, whether there's any bugs with games. They're not interested in SolidWorks or anything like that. So always try and run a Quattro card if you can, alright. Also you get things like FSAA, which is anti-aliasing, alright. So it's full screen anti-aliasing, and basically removes jagged edges from geometry, makes it look more crisp, alright. Full scene anti-aliasing, I should say, sorry. Sorry about that. Okay, last one is frames per second chart. So the Quattro range has changed recently. So the older cards are FX cards, then it went to a Q range of cards, so just standard Q 600, 2000, 4000, 5000. They go higher than that, they go 6000. And then they've just brought out a new range which is called K in front of it instead of Q, so it would have a K600, K2000, K3000. That stands for Kepler, and that is normally the number. The higher the number, the faster the card. It very much depends on what you're working with in SolidWorks. If you're designing coffee mugs all day, you could probably get away with quite a low card, so like a Q600 for instance. If you're working with power plants all day or something like that, you probably want something like a K5 or 6000. So yeah, it very much depends on what you're doing. Normally you want at least 15 frames per second. Anything less than that, it's not very nice, and you can actually tell it's juddering about. Okay. So just some examples of budget machines. So if you're watching this in future, this is set up around about October 2013, alright. So apologies if you watch this in the future and it's a bit out of date. But normally you'd either use for a lower end, you either use a Xeon, probably not a Xeon actually, I think that's probably wrong. You'd probably use an i7 or an i5, 2.8 gigahertz, Windows 7 or above, minimum of 1 gig NVIDIA Quattro K600, so Kepler 600. Memory, 8 gig minimum. No RAID is found in this machine. It just has a standard hard disk, 250 gig, and even that's probably quite small. The next one's a mid-range, so again, either this time you could probably get away with a Xeon or an i7. 3.3 gigahertz using turbo mode. All right, and then also Quattro K2000, 16 gig of RAM, no RAID, but it does have a solid state disk in it. And then the last one is two Xeons. You could either get away with that or the top of the range i7 Extreme, alright, which you can overclock to probably more than 3.3 these days. Windows 7 or 8, gotta be 64-bit. Video card K4000 or above, 32 gig of RAM. In this case, it's got two hard disks which are solid state, which are in RAID 1, so stripes, so they act as one, so very, very quick. And then we've got a hard disk in reserve. In this case, they've got two in RAID 1, so they're mirrored. Alright, but you could just have a standard one, to be honest. Okay, so that's hardware taken care of. Let's have a look at the environment. So, operating systems, we'll have a look at antivirus, shell and browser extensions, and then drivers and firmware. So again, have a look on the website if you want to know when what operating system is compatible with which version of SolidWorks. So as you can see from 2013, Windows XP is not supported anymore. XP is pretty old now, you know, it's been out well over 10 years, so I'm surprised they supported it this long, to be honest. Also, you can have a look at antivirus. Again, look on the website, there's loads of supported software there. I'd always recommend you run one of these, okay, rather than anything you've got. You know, it's all been tested. Try not to use shell or browser extensions, alright? So if you run lots of add-ins in Internet Explorer, for instance, if I open Notepad, it will load an extension into memory, alright, for Notepad to use. If you have too much open, alright, or running in your taskbar, alright, down by your clock, it can suck the life out of your machine quite quickly if you've got too much in there. So try and keep your machine as a professional tool if you can. Obviously sometimes that is difficult if it's a laptop and you take it home, and I know, but try and turn everything off that you don't need when when you're working in SolidWorks. Drivers and firmwares, always try and keep it up to date. Alright. Now another thing with drivers, especially graphics card, Windows Update is very, very good in what can happen is you'll have a specific service pack. That service pack will be linked to a specific driver, and then what's happened is over the course of say a month, NVIDIA have released a newer graphics driver. Windows Update has seen this and installed it without your knowledge, and then, for instance, we get phone calls sometimes saying, we've got weird things happening on screen, and the first thing was asked is like, have you checked your graphics driver? And then sometimes getting ahead of yourself, so using a graphics driver which is too new, can actually produce problems. So I say always try and keep it in date with or in line with whatever SolidWorks say. Drivers can, using the correct firmware as well. So that's like firmware is something that you have to. It's like the base. I think of the right word. It's like the base instruction set that the machine uses. All right. So like a BIOS, for instance, and by you making sure that you have the right firmware and drivers for your machine, it can improve stability and can improve speeds by up to a third. Last one very quickly is on networks. So you should be using a switch network. They're pretty standard these days, a lot quicker than old networks that used to be hub based. Alright, so switched networks they make direct connections between you and whatever you're trying to talk to. rather than throwing all the packets around the network like hubs used to. LAN speeds, you should really be using a gigabit network, alright, so a switched gigabit network. With broadband, depends where you live really. If you live in the middle of nowhere, your office is in the shed in the outback, it's not always ideal for some people, but try and get the best bandwidth connection you can get. It does make a difference, especially if you're trying to do a remote session with someone like us and trying to show us some supported item, and it's we can come and have a look and see what's on the screen. So having a good internet connection helps us, helps you. You can also get leased lines these days, which in turn reduces latency. Again, it's all cost related, but the general rule is, especially when you're on a LAN network, try and keep it to 1 gigabit or above. Okay, that is my talk on hardware over. I hope you've learned something, and hopefully see you again soon.